All right, for 2 trig functions, the unit circle. So we're going to introduce the unit circle here. All right, so let's pretend that we are dealing with this circle, x squared plus y squared equals 1. So if we remember our formula for circles, the formula is x squared plus y squared equals r squared. All right, so the key on this one is right here, saying that r squared equals 1, so that r equals 1. So the radius is 1. So we want to talk about a circle where the radius is always 1, no matter where we are in the circle. And that's called the unit circle, 1 unit. All right, and so as we go around, we're going to have an angle theta. We're always going to have 1 comma 0, or if we're up here, we'll have 0 comma 1. See if that comes back. There we go. And then as we come around here, what we're interested also in is how far we move along the circle itself, the S. And so this blue line here is just saying if we unwound the circle and pulled it into a straight line, how far would we go? So if we go 2 tick marks on the circle, that would be the same as 2 units going up if we unwound it. So we're just keeping track of how far we move along the circle. And that's going to be t. All right, so with that, we can figure out a couple different trig functions, and all 6 of them are sine, cosecant, cosine and secant, tangent, and cotangent. And so going along here, these are the flips of each other. Sine, if we remember from geometry, is opposite over hypotenuse. The cosecant is just the flip of that, hypotenuse over opposite. And so we do have this nice mnemonic, so, ca, toa, which says that the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So if we think about our circle, our unit circle, and we think about if we make a triangle that goes down to the x-axis, and this point is our x comma y, then from the inner angle, from the inside, the y is always going to be our opposite. And the h is always going to be the radius. The adjacent would be the x. And the hypotenuse is again going to be the radius. So we'll notice here that the sine is going to be y over r. And remember, in the unit circle, r is always equal to 1. So we'll have y over 1, which is the same as just saying y. So in this case, sine is always equal to y, cosine is x, and tangent is y over x. We're going to use those equations to solve some problems. Now this is the unit circle figured out for a number of different values. We're going to come back to this quite a bit, and so we're eventually going to need to memorize this whole thing. Now it looks like a lot to memorize, but really if you can memorize the first quadrant, you have the whole thing memorized, because every other quadrant is just a repeat of the first quadrant with the signs changed. Some negatives changed to positives, but other than that, the first quadrant and all the other quadrants are pretty much identical. So we'll talk a little bit more about that, but just know that we'll come back to this unit circle and all the values. All right, so let's go ahead and try some problems here. Example 1, evaluate the 6 trig functions at each real number. So let's make a little chart here. Sine, cosine, tangent, and then we're going to have the flips. The flip of sine is cosecant, the flip of cosine is secant, and the flip of tangent is cotangent. Okay, and so for our first one, we have pi over 6. And so we'll figure out our values for pi over 6. All right, so let's quickly flip back to our unit circle. At pi over 6, the angle pi over 6, we're going to look here and see that our x is root 3 over 2, and our y is 1/2. Root 3 over 2 and 1/2. So I'm going to flip back here. And we know that sine is the y. And so we know that the y value was 1/2. Cosine is the x. So the cosine here is √3/2. All right, so at this point, I'm not going to do the tangent. I'm going to jump straight to the cosecant because the cosecant is the flip of sine. So that's 2. The secant is the flip of cosine. So that's, I'm going to write it over here because we're going to have to do something to it. 2/√3, flip it over. You can't leave a radical in the denominator, so we're going to have to multiply and get 2√3/3. All right, so those are our values there. Now tangent is y over x, so 1/2 over √3/2. I'm going to multiply by the reciprocal and get 2/√3. Can't have a radical in the denominator though, so we're going to have to multiply it to the top, and we'll get √3/3. To flip that over, we'll just get √3 in the cotangent. All right, so we can do this for all the other values here. Let's try 5π/4. I'm going to flip back and take a peek and see what our x and y values are. At 5π/4, trying to find it, it's right down here. Both of our values are -√2/2. So we know our cosine and we know our sine immediately. -√2/2, -√2/2, and the flips of both of those are going to be both negatives, and we're going to have 2√2/2, which is just √2. All right, so if we divide two numbers that are exactly the same, we're going to get a tangent of 1. And if we flip 1 over, we also get 1 for the cotangent. Okay, so you can check the book if you need to for C and D, but they work the same way. You're looking at the x and y values of sine, cosine, the y for sine, x for cosine, and tangent is y over x. So go ahead and try one on your own. See if you can do 23. Find sine, cosine, and tangent for 11π/6. All right. I'm going to flip back, take a look at our unit circle. And 11π/6 has an x of √3/2 and a y of -1/2. So x is -√3/2, and the y is 1/2. So right away I know that the sine of 11π/6 is equal to the y value, which is equal to 1/2. The cosine of 11π/6 is equal to the x value, √3/2, and that's a negative. And then my tangent is going to be y over x. So my tangent is going to be 1/2 over √3/2. And so I'd multiply by the reciprocal. I'd get -1 over √3. The 2's would cancel out. Can't have a radical in the denominator, so we're going to have -√3/3 as our final answer.